Okay, so here we are at lesson 113, almost to the end of the book. In this lesson, it's more on adding and subtracting mixed measures and also multiplying by powers of 10. I'm not going to spend much time on adding and subtracting mixed measures because we've already done that. I'm sure that you guys have already had some practice at this, but I thought I would go over one subtraction problem. So when you have these mixed measures, you have to remember that when you borrow to subtract, for example, you have to remember how those units relate to one another. So in this example, we have feet and inches. So we have to remember that there are 12 inches in 1 foot. So right now we can't subtract because 8 is greater than 5 and we're trying to subtract. So we have to borrow from our 6. So when we borrow from the 6 feet, that becomes 5, but we have to not bring a 1 over like we normally do because we're coming from a power of 10 greater. Here we're coming from a perspective of 12 inches. So we have to add 12 inches to what's there. So 12 plus 5 is 17. So now when we subtract, we get 9 inches, 1 foot. Okay, so it's really important that you start learning all of these conversions because we're going to be doing unit multipliers and using our units for all kinds of things. And you will use this for the rest of your scientific and mathematical life. So it can be used in daily life and it's used in the classroom as well. So you have to learn those. The other part of this is multiplying by powers of 10. So this is not an example in your notes, but I thought I would just add in a couple of other examples to help us see what happens when we multiply by 10. Well, I think that you guys know that when you multiply 2 times 10, you would get 20. You basically, I think you probably learned you quote-unquote add a 0. But really what's happening is there's a decimal place there that you don't use because there's nothing after it. And you just move it over 1 because there's 1 0 in your 10. And now your 2 becomes 20. So 2.3, we would move the decimal point over 1 when it's multiplied by 10, and it would become 23. Well, what's 2 times 100? Well, that's 200. Well, what's 2.3 times 100? Becomes 230. Okay, in both cases, what we did was we moved the decimal point over twice. So you'll notice that the number of times we move the decimal point depends on the number of zeros that we're multiplying it by. Okay, 1 0, we move the decimal once. 2 zeros, we move the decimal twice. Okay, the other thing to make note of is that 100 is the same thing as 10 squared, right? So that exponent on your 10 tells you how many zeros are going to be in the number you're multiplying by. So now that we have 2.3 times 10 to the third, we know we've got to move that decimal point 3 places. 1, 2, 3. So we end up with 2,300. And when it's 2.3 times 10 to the fourth, it would be 23,000. Okay? Because we need to move that decimal over 4 times. In this lesson, you also have some problems like this. Actually, in your notes, it says, what is 1.5 million? So 1.5 million is, you could also think of it as 1.5 million. And you're supposed to write that in standard notation. That just means write it out. Instead of using the word million, you're going to write it out with the appropriate number of zeros. Half a billion. How much is half a billion? You can divide, but you really shouldn't need to. You should be able to kind of figure it out mentally. And I'm okay for you to write it out, but I'm also okay for you to figure it out mentally. And so in order to do that, one of the things I think might be helpful is to think on a smaller scale. So half of 100, I think you know, is 50. And half of 1,000 would be 500. So you can see how we end up adding an extra 0 between the two. So how about 1/4 of 100? Well, we know that 1/4 of $1 is a quarter, which is 25 cents. So 1/4 of 100 is 25. So how about 1/4 of 1,000? That would be 250. All right, I'm going to leave you guys to do the rest of your practice problems by yourself. I know you're fully capable to do those. If you have any questions at all, definitely contact me. Lesson 114 is about unit multipliers. And the good thing is I've already taught you these just basically, so it's going to be more practice at it. And the way I always like to talk about unit multipliers is that there are some times that we don't see why we should listen to people in authority. Like, it doesn't seem logical to us that we should do what, say, our parents are telling us to do or some other person in authority is telling us to do. Sometimes we just don't understand why. And unit multipliers tend to be that similar to that, you know. Like when you were little, you may not have understood why you needed to brush your teeth. But it doesn't take much exposure to people who haven't had access to toothbrushing materials, whose teeth are rotting, to understand, you know, that it is actually really a good thing to do, and it's beneficial to you. So there is a philosophical side to math sometimes where we learn that maybe our teachers want us to do things a certain way and we don't understand why. But I've talked to you about the fact that much of math and much of being a good math student has to do with building good habits. Just like teeth brushing is a good habit to build. Just like making your bed is a great habit to build. If you're not doing that right now, that would be a great habit for you to work on. It will actually improve your life over time. It's a way of learning self-control and self-discipline. So in the same way, I'm asking you to listen to what I'm telling you and to write out your unit multipliers, because once you hit chemistry, you will be using these concepts. It's called dimensional analysis, where you are converting things from one unit to another unit. And so if you get into these habits, it will benefit you in the long run. Just trust me on that one. So the first thing I wanted to do, I did write. Okay, so yes, I want you to write 2 unit multipliers for each of these separate things. 3 feet is 1 yard, 12 inches is 1 foot, and 1 kilometer is 1,000 meters. So I'm just going to write them in a different color. I think I'll choose green, kind of out to the side. So a way to write a unit multiplier is you're writing 2 equal measures as a fraction, and you're including the units when you write them. So 3 feet is 1 yard. Or 1 yard is 3 feet. Okay, you can write it either way. So how about this one here? We have 12 inches is 1 foot. And we have, or we can write it this way, 1 foot is 12 inches. 1 kilometer is 1,000 meters, or you can write it as 1,000 meters is 1 kilometer. Okay, so it's important that you understand that you can write these either way. It's basically, when you use these, you are multiplying by 1 because they're equal measures but using different units. So when you use unit multipliers, what you have to figure out is, which of these do I use? Do I use this one or do I use that one? Okay, we're going to jump down here to convert 30 feet to yards using 1 unit multiplier. The one above it is kind of just for fun. It's a little bit more challenging than using 1 unit multiplier. You have to think about how to use 2. But let's start off by just using 1 unit multiplier. We want to go from feet to yards. Now, this is how I always start, and I would like for you guys to get into the habit of starting this way. The reason is that you know your starting point. They give that to you, and you know where you need to end. And those 2 pieces of information direct you as to which unit multiplier to use. So we're going to write 30 in front of our feet because that's what we're changing, but we don't know how many yards it is yet. Now, some of you may be able to do that in your head, and that's fine and dandy. You just need to write out the unit multipliers in order to get credit for the answer you're given, the answer you give. So if you have a unit multiplier problem on your test, my expectation is that I will say a unit multiplier in your work. If I don't, then you have not answered that question correctly. Okay, so I'm not concerned in these unit multiplier questions. I'm not as concerned with the answer as I am seeing you develop a good habit in using unit multipliers. Okay, so the way you determine which unit multiplier to use, we know we're either going to use this one with feet on top and yards on the bottom, or we're going to use yards on top and feet on the bottom. All right, so what you want to keep in mind is that you always want to use the unit multiplier that has the thing you want in the end in the numerator. And the thing we want in the end is yards. So that means we're going to use this unit multiplier. Okay, so I'm going to erase that one. And I'm going to put in the unit multiplier we want. So 30 feet times 1 yard over 3 feet. Now we can, I'm going to go erase this. Now we can cross cancel. I'm going to use red to cross cancel. First thing you want to cross cancel is your units to make sure that you're using the correct units. This way our feet cross out, and that's really what we want. And now we can cross cancel with our numbers too. Our 3 becomes 1 and our 30 becomes 10. So our final answer is 30 feet is equal to 10 yards. Okay, and we did so by using a unit multiplier. What would happen if we needed to use 2 unit multipliers? Well, when we have problems like that, what we have to just figure out is, what 2 changes do they want us to make? I think I'll use blue this time. So we want to go from 3 kilometers. I'm going to just put that over 1, times a unit multiplier, which we're going to put here, times a different unit multiplier we're going to put there. And in the end, we want to get millimeters. All right, I'm going to move this box a little bit because it's a little too close. Okay, so kilometers, usually when you're going from kilometers to anything, you'll always go to meters first. So I'll put our unit multiplier in white. Well, let's talk about the 2 unit multipliers we could use. It's over here. All right, we could use 1 kilometer over 1,000 meters or 1,000 meters over 1 kilometer. In this case, what we want to make sure of is that we can cross-cancel our kilometers. So that means our kilometers have to be in the bottom. And that way we're going from kilometers to meters. So that's our unit multiplier. 1,000 meters is 1 kilometer. But now we want to go to millimeters. Well, let's cross-cancel our units here so we see where we're at. We're actually now at meters, and we want to go to millimeters. So that means we're going to want meters in the bottom, and we're going to want millimeters in the top. So hopefully your time tests have helped you learn these things, that there are 1,000 millimeters in 1 meter. Okay, and it looks to me like I'm going to have to move my units over. Move my millimeters way over here. Okay, so now we have 3 times 1,000 times 1,000. So that means we have a 3 followed by 6 zeros. Okay, so 3 kilometers is 3 million millimeters. Finish up those practice. Lesson 115 is about changing percentages to fractions. Writing percentages as fractions, which we've done a ton. But now we're going to be doing it with percentages that have fractions involved or mixed numbers. And it makes it a little bit more challenging, but I'm sure you guys will meet the challenge. So the first thing you want to do when you have a problem like that is to change your mixed number to an improper fraction. Then you divide by 100, keep, change, flip, and then you can reduce your answer. So let's start with 3 1/3. What is 3 1/3 as an improper fraction? Well, we have to multiply 3 times 3 plus 1. So that makes 10 over 3. And we're going to divide by 100. Why are we going to do that? What does percent mean? It means per hundredth. That's why we divide by 100. Now we keep, change, flip. 10 over 3 will keep, times is what we're changing, and we're going to flip 100, so that becomes 1 over 100. And look, we can cross cancel now that we're doing multiplication. This becomes a 10, this becomes a 1. So 3 1/3% as a fraction is 1/30. Let's look at 66 2/3. First step, let's change it to an improper fraction. So 3 times 66. If you're not sure, you can write it out to the side. It's going to be 198 plus 2 is 200. And remember, our denominator stays with what it was as a fraction, the fraction denominator. So 200 over 3 divided by 100. Now we keep, change, flip. Keep the 200 over 3. Change to multiplication. Flip the 100. And now we can cross cancel. 100 becomes 1. 200 becomes 2. And we find that it is 2/3, which in theory you have memorized, but practicing it like this is not a bad idea. lesson 116 is on compound interest. So in order to attract deposits, banks offer to pay interest, okay? And interest is a percent of the money deposited. A percentage. Okay, so that means you keep all of your money, plus they pay you a certain percentage of what you've put in. And we have a name for the money that you've put into the bank, and it is called principal. Okay, so that's your deposit. And that's what the bank might use to determine the amount of interest they pay you. So there's two kinds of interest. There's simple interest and there is compound interest. Simple interest is paid on the principal only. Whereas compound interest is paid on principal plus any interest accumulated. Okay, so my question to you is, which is better, to have your interest simple interest or compound interest? This is also something to think about when you think about credit cards, because credit cards can be really dangerous, and I think a lot of people don't understand how they work. But you will understand because you are learning about it. So what will happen if you're only calculating simple interest, it does not grow very fast. Okay, so your dollar amount grows slowly. But compound interest, it grows much faster. Okay, and the reality is that when you take out a credit card, what you're doing is you're borrowing money, and they charge you way more to borrow money than any bank would ever pay you to borrow your money. So what can happen, and what happens to a lot of people, is they buy things that they don't have money for right now, thinking, well, I don't have the money right now, but I'll have the money later. But when the money comes in later, they don't pay off what they borrowed. Instead, they use that money to buy something else that they want. So it's something to be really mindful of and careful of, because they can basically make you a slave to the credit card companies. So just be really careful with that. All right, so $2,000 compounded annually. This is Sam's story, our very first problem. And he's earning 10% interest compounded annually, which means every year. Now, you will not find 10% interest in a savings account. Okay, so those are unrealistic numbers. You don't get paid 10% to deposit your money in the bank, unfortunately. So the question says, if she does not withdraw any money from the account, how much money will be in the account after 1 year, after 2 years, and after three years? Okay, so the fact that it's compounded annually means that at the end of 1 year, she'll have $2,000 plus whatever she earned in interest. Okay, so first thing we have to discover is how much does she earn in interest. So we have to change our percent to a decimal, so that's 0.1. And so we end up with, she earns $200. Okay, now if we had, so at the end of 1 year, she has her $2,000 plus the $200. So $2,200 after 1 year. So in year 2, she's going to earn interest on that $2,200. Now, we just multiplied by 0.1, but if we had multiplied by 1.1, then we would have not needed this extra step of addition. It would have been within our problem. Okay, let's see how that works. So 0, 0, 0, 2, placeholder 0, 0, 0, 0, 2, 0, 0, 0, 2, 2, and we've got to come over 1 because we have 1 decimal place in our problem. So you see how you can combine them both by adding a 1 in front. Okay, let's do it that way for year 2. So in year 2, after 2 years, we would multiply again by 1.1, 0, 0, 2, 2, placeholder 0, 0, 0, 2, 2. Obviously 10% is an easy thing to multiply by. 2, 4, 2. So at the end of 2 years, she has $2,420. And so that's the amount we'll use to figure out what she has after 3 years. Well, we multiply again by 1.1. Placeholder 0. Should have come over further, I guess. 2, 6, 6, 2. All right, so at the end of 3 years, she has $2,662. Now, what would she have earned if it was not compounded annually? Well, we know that 10% on her principal is $200. So if she had not, if her money had not been compounded annually, she would have earned $200 each year. So she would have started with $2,000. Okay, then this year she would have $2,200, but she would only get $200 again. So this year she would have $2,400. She would have gotten $200 again, and at the end of the year she would have had $2,600. All right, so in this example it's only $62 more, but wouldn't you rather have $62 more than $62 less? And the larger the amount you put in, the more interest you're earning. All right, do the rest of those story problems on your own, and if you have any questions, we can talk about it. Actually, I do want to say that you can use a calculator to calculate the second and third